Real column for steel material. So real column design using steel materials. So it could be there are two different types of common materials, like structural steel. You can think of like an I-beam, looks like that, cross section. And then machine parts, you can think of like a piston connecting rod, like this very simplified one. So it could be machine parts, or it could be anything that actually loaded is considered column. It doesn't have to stand like that to be a column. It could be sitting like this, and then load is as long as the load is axial, then that is become column. On the other hand, beam is load is some like this, cross-sectional. So if there is axial load, we call column. So for structural steel, there is a transition criteria, KL by R, the slenderness ratio, if that is equal to this. So this is the transition criteria. If the slenderness ratio is more than 4.71 is square root of modulus of elasticity and divide by the yield strength. If the cylinder ratio is more than this, then we call that a slender column or tall column, and then we can use this equation to calculate the load. Allowable load is calculated by 0.525 Euler stress times the cross-sectional area. The Euler stress, we have discussed that in the earlier video, can be found from those equations. Now intermediate column, if KL by R is less than equal to this transition value, and then the formula would be P allowable, the load, critical load allowable, is calculated by this formula. Now oftentimes this is a complex formula. The way it is written is basically you can put this factor of safety this side, then it becomes basically PA 1.67 is equal to this FY by FE, and then FYA. You could also bring this into this side depending on what is given, so for the simplification of calculation. Now machine parts, same thing, slender column. If the transition value 2 pi square E by Fy instead of 1.47 EI by Fy, but you don't have to memorize anything, just write it down. The transition is calculated by 2 pi square E divided by Fy. So cylinder column, if the slenderness ratio is more than that, then use this simple equation, like almost like an Euler equation. Same thing here, very close to Euler equation, other than this factor of safety. Now intermediate column, then the equation becomes a little bit complicated. So if it's intermediate column, this is the equation. Oftentimes if you write the equation like that, just a little bit rearrange it, it's very difficult to put this in the calculator, this whole thing. So it's easier if we just do a little modification and then put this. So you need to do a little bit of algebra before we put this in a calculator. That gets a little bit easier calculation. So that's about the real column.